Lesson 42, finding permutations and combinations. So before we begin, we're just going to review factorial. So if you remember, factorial is just a number that has an explanation point by it. So n factorial doesn't mean that n is super excited. It's actually a multiplication term where you take n times the number right before it, times the number before that, times 3 numbers before the number, all the way down to 1. So for example, 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1, which is 720. Kind of don't like the way this n looks. Let me fix it. With permutations, order matters. So if I were going to give like a first, second, and third in our classroom, the order would matter. So that would be considered a permutation. The permutation of n objects taken r at a time. I'm going to give you the formula for that. So it looks like this. We do a capital P and then n comma r. That stands for n objects taken r at a time. It is equal to n factorial divided by n minus r factorial. And here's just an example of evaluating with factorials. So if we had 5 factorial divided by 2 factorial times 5 minus 2 parentheses factorial. So we could look at this as 5 times 4 times 3 times 2 times 1 over 2 times 1 times 5 minus 2 is 3. 3 factorial is 3 times 2 times 1. So we could do some canceling. 2 goes into 4 twice, and the answer would be 10. So that's just kind of an example of using factorials. Okay. We're going to look at the word Mississippi because it has lots of S's, lots of P's, and lots of I's in it. So M-I-S-S-I-S-S-I-P-P. The word Mississippi, we want to know how many distinguishable permutations in this word using, well, we'll just put of letters, M, I, S, and P. So if we count up all the letters in Mississippi, we have 11 letters total. There's 1 M, 4 I's, 4 S's, and 2 P's. So the formula that we're going to use is, it's actually found in your book with an example, I think. I can't remember, but it's the permutation. You take the total number of letters, then you have to divide out q sub 1, factorial, and I'll tell you what each of those means. So n is the number of letters. In this case, it would be 11. Q sub 1 is just the number of m's. Q sub 2, in this case, would be the number of i's. Q sub 3 is the number of s's. and q sub 4 is the number of p's. So we would just plug into this. We get p equals, we'd have 11 factorial over 1 factorial 4 times 4 factorial times 4 factorial times 2 factorial. So when I do this, because I know 4 factorial is my biggest in the denominator, I'm going to write 11 factorial as 11 times 10, and I'm going to go all the way down to 4 and just leave it as a 4 factorial. 10, 9, 8, 7, 6, 5, and then 4 factorial. Because 4 times 3 times 2 times 1 is just 4 factorial. That's going to be easier for me to cancel one of these 4 factorial. 1 factorial is just 1. 2 factorial is just 2. So we have 2 times 4 times 3 times 2 times 1, and then times this 4 factorial. So I left 1 like this so I could just cancel those 2. 2 times 3 is 6, so I'm going to times those and cancel that one. 4 times 2 is 8, so I'll cancel that one. So I just have 11 times 10 times 9 times 7 times 5, which I've already done. It's 34,650. So this is how many distinguishable permutations, that means different, using these letters, M, I, S, and P, from the word Mississippi. Oh, there is one thing you need to know about factorial, and that is that 0 factorial equals 1. So we have to keep that in mind. If you ever see a 0 factorial, that just means 1. The next part of the lesson is about combinations, and that just means order doesn't matter. So for instance, if I were just to pick 3 students out of the class, the order wouldn't matter. It's not like a first, second, third. It's just 3 out of 5. So combinations, order doesn't matter. I'm going to turn the page. I can go back after, okay, Sam? So, combinations. So, the formula for combinations of n objects taken r at a time is just n factorial divided by r factorial times n minus r factorial. So if I wanted to find the combinations of 10 items taken 3 at a time, we would just do 10 factorial over 3 factorial times 7 factorial. So I'm going to do the same thing as before. My denominator, the biggest factorial, is 7. So I'm just going to go down to 7 on 10 factorial. So 10, 9, 8 times 7 factorial over 3 times 2 times 7 factorial. I'm just leaving out the times 1. So I can cancel the 7 factorials. 3 goes into 9 3 times, 2 goes into 8 4 times, so I have 12 times 10, or 120 ways to choose 3 objects out of 10. So there is an example, a word. I'm just going to do one story problem, and then we'll be done with the notes. So how many committees, so we're putting together a committee, can be selected from a set of 5 boys and 6 girls if each committee is to include 3 boys and 2 girls. So we have to find the combination, like the number of ways to choose 3 boys out of 5, and times it by the number of ways to choose 2 girls out of 6. So we're going to do the combination of 5 choose 3 times the combination of 6 choose 2. And then we just use the formula. So we have 5 factorial over 3 factorial times 2 factorial. Then we multiply that by 6 factorial over 2 factorial times 6 minus 2, 4 factorial. So I'm going to do the 5 for 3 factorial divided by 3 factorial times 2. And I'm going to do 6, 5, 4 factorial over 2 times 4 factorial. Then I can cancel. Cancel here. 2 goes into 4 twice. 2 goes into 6 3 times. And I'm basically, 5 times 2 is 10, times 3 times 5 is 150. So there's 150 ways to choose a committee of 3 boys and 2 girls out of 5 boys and 6 girls. And that's the end of the lesson.